Alright, welcome to Study Guide Review, Episode 3, Revenge of the Sith. The last things we're going to cover are determining the ionic charge of each element, and then write the symbol and name form of ionic and covalent bonds. So I'm going to switch screens again here, and I'm going to write out some ionic charge, determining how to identify the ionic charge of each element. Alright, the ionic charge of an element is determined by its valence electrons. So ionic charge drop my I there, is determined by the valence electrons. Okay, so if I pick just any element at random, the ionic charge is determined by the valence electrons. And then one other shortcut we had for this, if you look at your periodic table, we wrote our cheat guide here for ionic charge. So here's the top of our table. We have group 1, 2, and then groups 3 through 12. And then group 18 over here, 17, 16, 15, 14, and 13. Alright, so group 1, starting with hydrogen, and then lithium, and then on down the periodic table. Everything in that group is going to have a +1 charge. So hydrogen, with 1 valence electron, it's going to get rid of that valence electron. So if that goes away, my hydrogen now has no valence electrons. It lost a negative charge, so it's going to become a +1. If I look in group 2, which starts with beryllium, and then magnesium, and then on down, these are all +2. Okay, so like if I look at beryllium, it has 2 valence electrons, 2 extra electrons. It's going to get rid of both of those electrons. So then Be lost 2 negative charges, it's going to be a +2. Everything in this section here, all these metals, you have to just look at each one and determine how many valence electrons it has. Most of them are 1s and 2s. Okay, so they're either going to be a +1 or a +2, but they're generally mixed, so you'll have to look at them. Alright, next we come over here to group 13. These are all +3 elements, starting with boron and aluminum. Okay, so if I take boron with its 3 valence electrons, it's going to give those 3 away. It's going to transfer them to another element when it forms an ionic bond. So I'm going to have boron +3. Now, this middle section is special. This next column, it's going to be plus or minus. Write that differently. Plus or minus 4. So if I look at carbon and silicon and everything in this group, it has 4 valence electrons. So it can do one of 2 things. Either it can give those 4 away, and then it becomes carbon +4, or, because it's just this transition point, it has 4, it can take on 4 more electrons to get its octet. Instead of 8, bring on 4 more electrons, and then I get a carbon -4. 4 more negative charges gives me a carbon -4 for a charge. Okay, our next row, these are going to be the -3, and that is nitrogen, phosphorus, and on down. So nitrogen already has 5. So it is missing 3 electrons. It needs 3 more. If it brings on 3 more electrons, 3 more negative charges, nitrogen is a -3. Next, we have oxygen and sulfur. On down, these are going to be -2. Because oxygen already has 6. Draw them over here. And it's going to take on 2 more. 1, 2. 2 more negative electrons gives me O -2. Okay, then we have fluorine and chlorine. Those are -1. So fluorine has 7 already. 1, 2, 3, 4, 5, 6, 7. It needs 1 more electron right there. If it brings on 1 more negative charge, fluorine is a -1. And then finally, our last group here, these are going to be our zeros. These are our noble gases: helium, neon, argon. They tend not to bond with anything else because they already have a full outer shell. Helium, it has 2. Remember in the last video, or the video before that, we mentioned that first orbital, the first shell, the first energy level that's occupied in helium, it can only fit 2 electrons, so it has a full outer shell. Aside from hydrogen and helium, everything else is trying to get to 8. So neon is the first element on the periodic table that has all 8 in that second energy level. It has a full outer shell. It doesn't need to take on or give away any of its electrons, so it is stable already. So it's not going to be a plus or minus anything. It's just going to be neon. And the same thing on down that list. Okay, so that's how to determine ionic charge. And that's going to be important when you are combining elements. Let me start a new layer here. So let's look back at the example we were just doing. In the last video, we have RB and BR, right? We had to end up putting those together at some point to get the rubidium bromide that we used in that chemical reaction statement. So if I look at my periodic table and find rubidium again, okay, it's in group 1, period 5, so everything in group 1 has a +1 charge. Rubidium has 1 extra valence electron, it's going to get rid of it. I'm putting that together with bromine. If I find bromine, it's over in group 17, period 4. It's element number 35, has 7 valence electrons. Everything in group 17 is a -1. Okay, if I go to put those together, I need to balance out my charges. And in this one, +1, -1, they're already balanced. So we do that whole crisscross thing we talked about. So we have rubidium and bromine. We do those crisscrosses. That -1 comes down here, becomes a 1 for rubidium. The +1 comes down here, becomes a 1 for bromine. And then if it's the elements listed, we don't need to write the 1, so it's just RB, BR. Let's do one that's a little more complicated one we did in class. We'll do aluminum plus oxygen. Okay, I find aluminum on my periodic table has 3 valence electrons, 1, 2, 3. If I find oxygen, it has 6. 1, 2, 3, 4, 5, 6. And you know what? I'm going to change the color of my aluminum. Okay, aluminum, it's 3 valence electrons. Now, aluminum wants to get rid of its 3 electrons. It can give one of these to oxygen. It can give a second one to oxygen. Now my oxygen has 8, so it's good. But my aluminum still has an extra valence electron. So I'm going to add another oxygen atom, which has 6 valence electrons. Still missing 2. It can take 1 from this aluminum. Now my aluminum's happy, it's gotten rid of all 3 of its electrons. But I'm still missing a spot here on the oxygen, so I'll add another aluminum with 3 valence electrons. One of these can go here. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is happy. But I still have 2 extra electrons on this aluminum atom now. So I'm going to add another oxygen with 6 valence electrons. It's missing 2. I'm going to take 1 from this aluminum, put it there, 1 from here, and put it there. I now have 1, 2, 3, 4, 5, 6, 7, 8 on this oxygen, and I have gotten rid of all 3 on this aluminum. All of my atoms are now stable. They've gotten rid of all of their extra or filled in all their missing spots. So if I count that up, I have 2 aluminum, and I have 3 oxygen, Al2O3. Now, this is one method you can go about trying to figure out how many of each atom you get in your ionic compound. The other way is like we were doing over here. Aluminum. Aluminum's not green, that's yellow. Aluminum. If I look at my periodic table, it is in group 13. It is a +3 for ionic charge. Oxygen. Oxygen is in group 16, so it's a -2. Okay, if I crisscross my numbers, it should just be the numbers, not the plus and minus signs. I have Al with a 2. 2 comes from here. And I have O, and the 3 comes from up there. If I look, these 2 answers are the same. Okay, so no matter which way you want to do it, if you want to go through the dot structure process and transfer the electrons from place to place and count up how many of each element you need, that's fine. You get the right answer. If you want to do the shortcut and use your periodic table and find the valence number and then find the ionic charge of each element and then just crisscross the numbers, that's fine too, because you end up with the same answer. Alright, so next we're going to look at the last thing for this study guide, and then you guys should be ready for your test. Okay, so this last thing is write the symbol and name form of ionic and covalent bonds. So symbol and name form, that goes back to what we were doing when we had the rubidium bromide plus potassium. Well, take a look at that one again really quick. Or actually, I'll do a covalent bond really quick just to show you guys how those the names work. So I'm going to use the example N4O6. That was in that covalent bonds review assignment we did last week. So the first step, obviously we said it's a covalent bond, we're going to just check. So I got to find nitrogen on my periodic table. I find it is nonmetal. Then I got to find oxygen in my periodic table. It's right next to nitrogen. It is also in the right part of the periodic table, which is again a non-metal. So if I put 2 non-metals together, non-metal and a non-metal equals a covalent bond. So when we're doing covalent bonds, this is when we have to use those prefixes. So 4 is tetra, like Tetris. Tetra nitrogen. So I keep the name of the first element. And then 6 is hexa. But remember, if I'm using oxygen, I'm going to drop the A and I change the ending hexoxide. That's all I have time for. My video is about to shut